Hi, I'm Rich with insideHPC. We're here at SC16 in Salt Lake City, and I'm here with some folks from the Exascale Computing Project. Paul and Stephen, welcome to Salt Lake City.
Good morning, Rich.
Thank you very much.
Well, thanks for coming. I guess, Paul, we should start with you. Can you bring me up to speed? What's been, happening with the Exascale Computing Project?
Sure, Rich. Well, just in this past week, we've made two major announcements. We've selected and started funding 4 co-design centers that will play a big role in developing better methods for some commonly used computations for science and engineering. We also announced 35 software projects to fill in the software stack that's needed for Exascale, things like compilers, tools to measure performance, and programming languages. Prior to that, we also announced 22 application teams that will be developing important applications in many areas of science, engineering, national security, and even precision medicine. The last one jointly with the National Institutes of Health and the National Cancer Institute. So finally, we can tell you what we've been doing. ECP is a year old. We've been gearing up to this, and just in the last few weeks, we can now tell you these are among the first projects that will be addressing Exascale over the next few years.
Okay, Paul, so if you're not going to buy supercomputers with this project, why is there a need for the Exascale Computing Project?
Well, the reason there's a need is, of course, technologies have reached their limits in some areas, the so-called Moore's Law and the Dennard scaling. So that means that future vendor products at the very high end will need to be fairly different. And so and the vendors, I think, need a little bit of incentive from us, frankly, to take that step in the time frame that matters for us. Eventually, Exascale systems would happen anyway, but it might take much longer. And also, if we don't specify what our needs are, for example, we want to keep the energy level to no more than 30 megawatts, hopefully 20 megawatts per system. Without that push, we might end up with systems to buy that take 55 megawatts, just as an example. So I think it's because we need to speed things up and because there's a lot more R&D needed at this time, both for the hardware and for the applications and the software, which is why we're funding co-design centers, software projects, and applications.
Because this is a daunting technical problem, right? To get to Exascale from where we are today, isn't it, Steve?
Yes, it is. And the way I like to think of this is in terms of gaps. And one of the things ECP is trying to do is close some of these gaps so that we're ready for Exascale on the time frame that we need it. That was a key statement that Paul made, because there's certain simulations that need to happen, for science and for national security that need to happen at a certain pace and a certain cadence. And we can't necessarily wait for computing to catch up to where it needs to be for our applications that are important. We have to kind of evolve both together, and that's why one of the biggest components of ECP is co-design, where we work with the vendors, we work with the application developers, we work with the software developers to build that whole ecosystem with the vendors to try to prepare us for that future.
Well, I want to step back. A question for you, Stephen. And I've heard there's some misconceptions about what Exascale Compute Project is. Can you help clear that up for us?
Sure. So one of the things that we're actually doing is we're building this ecosystem and the applications, and we're investing in technologies, and we're sort of this bow way preparing for Exascale. But we're not, the project itself is not building or purchasing Exascale computers. We're leveraging the existing procurement processes that DOE has and NSA have for their computing. So we're preparing the ecosystem and that entire infrastructure, if you will, for Exascale for the future. So it's very exciting. We're doing that much larger piece of preparation.
Okay, so who will be doing the actual procurement then?
The Office of Science and NNSA program. So the ASC program and the Office of Science programs will be doing those procurements through those facilities.
Okay,
Yeah, the facilities that usually get the big systems will be the ones doing the procurement. Yeah. And in building the ecosystem, I might add that we are working with the vendors, giving them some funding that will be announced later to develop better systems for us. But that's just new developments in hardware and technologies that hopefully will become part of the products that the facilities will buy for Exascale.
Okay. So Paul, how many years are we talking about? Is this an 8-year project, 10-year, beyond? What would you say?
Well, the duration of projects has been under discussion. Right now, the most likely is 7 years. Mm-hmm. We started out with a 10-year project timeline, and right now we're aiming closer to 7 years. It's still in flux, but that's the most likely. A 7-year project, still pretty long.